Show that the point 2, 4 lies on the curve x cubed plus y cubed minus 9xy equals 0. Then find the equation of the tangent and normal line to the curve at the point 2, 4. The point lies on the graph if it satisfies the equation of the graph. This means if we were to plug the point x, y, which is 2, 4, into the equation, equality holds. And that is what we need to check. X cubed plus y cubed minus 9xy equal to 0, where x is 2 and y is 4. And so we replace x with 2 and y with 4. And we need to check if this is indeed 0. 2 squared is 4. 4 times 2 is 8. So 2 cubed is 8. 4 times 4 times 4 is 64. 2 times 4 is 8. 9 times 8 is 72. And so this is 72 minus 72, so indeed it is 0. So yes, we conclude that the point lies on the curve. To find the equation of the tangent and the normal at that point, we first need to find the slope of the tangent line, which is dy dx. The equation given is x cubed plus y cubed minus 9xy equals 0, which is not in explicit form. And so we will need to use implicit differentiation. We differentiate both sides of the equation with respect to x because we want dy dx. dy dx is the slope of the tangent line. This is the derivative of the sum and the difference, so we would find the derivative of each of its terms separately. The derivative of x cubed with respect to x, the derivative of y cubed with respect to x, and the derivative of 9xy with respect to x, and then the derivative of 0 with respect to x. The derivative of x cubed with respect to x is the normal regular derivative, which is 3x squared. The derivative of y cubed with respect to x. And so we're taking derivative of an expression that does not have the same variable of differentiation. So this will be implicit. But first, the derivative of y cubed is 3y squared, but because it's not the same variable dx, we would need to multiply dy dx or y prime. The derivative of 9xy, it is a product, so we will use the product rule. First, the derivative of 9x with respect to x is 9 times the other factor plus, and then we keep the first factor 9x. The derivative of y with respect to x is dy dx, and on the right hand side, the derivative of 0 is 0. And so we have 3x squared plus 3y squared y prime minus 9y minus 9xy prime equals 0. We can just leave this at dy dx, but dy dx is y prime. Next, we group all of the term with y prime to the left hand side. So 3y squared y prime minus 9xy prime, and any term that does not have y prime in it, we moved it to the right hand side. So negative 9y, move it to the right hand side, positive 9y. Positive 3x squared, move it to the right hand side, minus 3x squared. Next, we factor out y prime. Factor out y prime. The first term will leave us 3y squared, and the second term will leave us negative 9x. The right hand side is 9y minus 3x squared. And so now we have y prime as a factor, and so we can isolate y prime. Y prime is 9y minus 3x squared over 3y squared minus 9x. This is the derivative of the function that was defined implicitly. This derivative is the dy dx, which give us the slope of the tangent line. To find the slope of the tangent line at the point 2, 4, we plugged in x equals 2 and y equals 4 into this derivative. Everywhere we see a y, we would replace it with 4. Everywhere we see an x, we would replace it with 2. And so the slope of the tangent line is 9 times 4 minus 3 times 2 squared over 3 times 4 squared minus 9 times 2, where x is 2 and y is 4. Yes, we should have simplified this further, but we're interested in the number for the slope of the tangent line, so it is okay not to simplify this. The numerator is 36 minus 3 times 4 is 12. The denominator is 16 times 3 is 48, and 9 times 2 is 18. And so this is 36 minus 12, which is 24, and 48 minus 18 is 30. We simplify this further. 24 over 30, which is 0.8, but we should not use fraction. This is 4 over 5. And so the slope of the tangent line is 4 over 5, and the point is 2, 4. These are all we need to write the equation of the tangent line. The equation of the tangent line is y minus y naught equals m x minus x naught. And the equation of the normal line had the slope of the negative reciprocal of the tangent line, and the point is still the same point. And so the normal line is y minus 4 equals negative 5 over 4, and then x minus 2. There is a good chance that we have to isolate y, and so this is y equals 4 over 5x minus 8 over 5 plus 4. And so this is 4 over 5x minus 8 plus 20 is plus 12. 12 over 5. And then for the second equation, y equals negative 5 over 4x. Distribute the negative 5 over 4. We have plus 10 over 4. And we bring the negative 4 over. And so this is negative 5 over 4x plus 10 over 4 plus 16 over 4, so that we have the common denominator. And so the normal line is y equals negative 5 over 4x plus 26 over 4. But 26 over 4 is 13 over 2.